Dr. Joseph Richards, postdoc in the Center for Time-Domain Informatics here at UC Berkeley. And I'm here to tell you about an exciting new catalog of variable stars called the Machine Learned ASAS Classification Catalog, or MACC for short. The catalog is generated by a set of algorithms that were trained to make probabilistic statements about the classification of more than 50,000 variable stars in the public all-sky automated survey. Basically, we train machines to use previous knowledge in a small sample of these stars to make predictions about the whole set. In total, there are 28 different classes of variable star in MACC, and now they are all available to you. Our paper on the methodology and results has been submitted to an astronomy journal. Today, I wanted to introduce you to the public interface to MACC, found at www.bigmac.info. There are, of course, many catalogs out on the market you can use for your variable star needs, but we think Big Mac is something special. First, it builds upon the sum total of classification knowledge of all the stars in the catalog and other catalogs. It makes use of ancillary data on each source to improve the classification. It provides a metric of how anomalous each star is compared to stars of known variability. And most important, it provides well-calibrated probabilistic classification statements that allow you to dial in your own demographic priors on all the classes. With finite and imperfect data, no star belongs definitely to one class or another, and we think MACC reflects this inherent uncertainty well. This is a first for an astronomical catalog of this size. Now let's take a look at the public face of this catalog. First, we will demonstrate how easy it is to interact with the MACC catalog. From the home page, we can explore the catalog by running queries, browsing by class, or visualizing the data. Let's begin by browsing the catalog by classification. Here, for your convenience, we allow simple querying of all objects for a MACC class, and a class hierarchy to guide you through the taxonomy of variable stars. Let's see how we can select all fundamental mode RR Lyrae by clicking the drop-down menu. Alternatively, we can explore the phenomenological hierarchy of variable star classes using the tree provided at the top of the page. MACC provides dozens of attributes for each ASAS source, including ASAS and .astro IDs, positional information, class probabilities, anomaly scores, and much, much more. We can explore the data by sorting on any of these attributes. First, let's sort on probability of RR Lyrae fundamental mode. We see that several, but not all, of the top RR Lyrae candidates are members of the MACC training set, which was employed to train the machine learned classification algorithm. At any time, we can customize the table by adding or removing columns, or save the query results to a file. Note that the Home, About, Contact, and FAQ pages are always accessible. Let's take a further look at one of the top RR Lyrae candidates. If we click on the .astro ID of a source, we are taken to a web page of information on that source. Let's do that. On this page, we supply important information about the object of interest, including a plot of the ASAS light curve, positional information, links to SIMBAD, NVO datascope, and ACVS, and a probability histogram for a few of the top MACC classes. Additionally, we allow you, the user, to leave comments about that source, like it, or share it with all of your Facebook and Google Plus friends. We're already fielding questions about MACC. This is one we got from Lonely Girl 19. She writes, "Dear MACC people, I'm interested in finding anomalous outliers that don't seem to fit any of your established classes, yet have well-defined periods between 1 and 100 days. Let's try to do that." Here we are at the www.bigmac.info homepage once again. We can run custom SQL queries through the Query page. The Query page allows us to run basic queries on the MACC catalog, or more advanced queries on the classifications and light curve features. Additionally, we can run positional queries around a given RA and DEC. And, of course, we can always write the results of any query to file. Now let's see how we can perform Lonely Girl 19's query. She wants to find any object whose period P is between 1 and 100 days, and whose anomaly score is large. The rule of thumb is that outliers are objects whose anomaly score is greater than 10.0. Let's put that in and run the query. So we find 458 objects satisfying these criteria. And, as before, we can now interact with the results of the query by, for example, sorting on the statistical significance of the period, or clicking on an object to find more information about that source. That's all for this introduction to MACC. Thank you for joining us. I hope you're as excited about MACC as we are here at the Center for Time-Domain Informatics. And of course, if you have any questions or comments, we would love to hear from you. Enjoy!